Hello, this is Mr. Lorenz with a video lesson for Unit 6, Lesson 2, which is testing a claim comparing two independent means. So a little background on this video. I just shot the whole video and somehow it didn't record, so my notes are already filled in, and this one's going to be a little bit different because I'm just going to walk you through what I did, so I don't have to go through and fill out all the notes again. So this video will go a little bit quicker, but feel free to pause it and take your time going through it, even though this will be a pretty short video. So the big thing we got to get into with this lesson is it's comparing independent means. Independent means is not a vocab term you've learned yet, so that's something we have to talk about. So we're still going to have two samples, two populations. It might be men and women, it might be old and young, rich and poor. They don't have to be opposites. It's just going to be two different populations. It could be Glenbard East students and Glenbard South students. If the two populations have a direct link between them, so you have population 1 being husbands and population 2 being wives, and every piece of data comes from a relationship. So here's the husband's annual income, here's the wife's annual income. There's a direct link from population 1 to population 2. This is a dependent sample, or a dependent set of populations. The sample sizes have to be the exact same, and every value from population 1 has a little buddy in population 2 that matches up with it. That's something we're going to dive deep into in the next lesson. For today's lesson, we're really going to just focus on independent means, which is going to be really similar to independent proportions, which we did in the last lesson. So it's just two samples from two populations. There's no relationship necessarily between the individual data values. This is going to look really familiar to you. This is our set of steps, which has not changed for 2 units now. So today's sample problem, the first one we're going to do is talking about the amount of words men and women use in a given day. So what we've done is we've used some kind of word tracker to track how many words a day men and women are using, and out of 186 men we have this many average words and this standard deviation, and for 210 women we have this mean and this standard deviation. You notice I've gone in and called this first population population 1 and this population population 2, and I've put a little subscript of an N1, X bar 1, S1, and then N2, X bar 2, S2 on this side. We need to do that. We need to separate what statistics come from the first population and which come from the second. We're going to test the claim that men and women are equal talkers. So when we get into our hypotheses and we're dealing with equal talkers, that means we're not suggesting that one talks less or more than the other. So the only alternative hypothesis that we have here is to say that they're not equal to each other. If we don't have a claim of greater than or less than, we have to just say that they're not equal to each other. Okay, so that's what I've said as my alternative hypothesis. I've said that it is not equal to. Okay, now significance level, they didn't tell us a significance level for this problem, so I chose to use 0.05 because this doesn't seem like the most significant problem in the world, that we're life or death and have to worry about it being a 0.01. So here's our new test statistic. Pretty straightforward, all a bunch of letters that you're familiar with. We've got our N1, N2, X1, X2, etc. This formula kind of looks like the proportion one. You just have to take the information from the first population, plug it in, and take the information from the second population and plug it in. So you'll see that I have already done that. Here's the first X bar from up above's information. Here's the second X bar from up above's information. Here's my first S1. Here's my S2. Those are standard deviations. N1 and N2. And I plugged all those in, and I was careful to put parentheses around my numerator, and I was careful to put parentheses around each of the individual fractions that went into the denominator. I put that all into my calculator, and I got an answer of negative 0.676. So I would suggest pausing the video, typing this in, making sure you match my answer, and reaching out if you're not. Now, onto the p-value. This is a little bit different, just a little bit. You notice up above this was a t-test statistic, which means we need t-CDF to find the p-val. So I am going to, because it was a less than problem, okay, this was a less than problem, as you see in the alternate, oh, sorry, not a less than, this is a not equal to problem. So it's a not equal to, and my test statistic is negative, so I go to the left, as I've drawn here, and then I have to multiply by 2, okay? And now that I'm looking back at it, I don't think I did that the first time, so I gotta make sure I fix it. It's good that I'm going through a second time, I guess. Okay, multiply by 2, that's gonna give me an answer of 0.5 as my p-val. Now, something you might notice about this problem, it's a little weird. I'm going to the left, so negative 10, that's not weird. There's my test statistic, that's not weird. This is a little weird. Remember T needs degrees of freedom? Well, for degrees of freedom, we're going to take the larger n from the two samples. So two samples had a 186 or a 210 as their n's. I'm going to take the larger one, 210, and I'm going to subtract 1 from it. And that's going to be our degrees of freedom. So that's how I got the 209 there. That's always what you're going to do. You can take the bigger n and subtract 1. Then I multiply by 2 and I get a p-value of 0.5. Now I got to fix this because I was wrong about that. So 0.5 being my p-val, it's still a false. It's still not true that it's less than 0.05. That led us to fail to reject, giving us a conclusion that there is not sufficient evidence to show that men and women are not equal talkers. So remember, we're always talking about the alternative hypothesis. Well, the alternative hypothesis here said the men average and the female average are not the same. So that's what I have to say in my conclusion. I didn't show that they're not the same. So there's not sufficient evidence to show that men and women are not equal talkers, which basically says we think that they might be equal talkers because I can't show that they're not. And that's it for that problem. So now we're going to do a faster one that's all put together and set up for us. Okay, so as part of the National Health Service, data were collected for the weights of men and women, men in 2 different age groups. So here's our first set of information that tells us that there's 804 younger men, 25 to 34, who have a mean of 176 and a standard deviation of 35. And then there's a second set of information for older men, age 65 to 74, and their mean and standard deviation. Now, this first step is actually really important. I set up which population's which. I called the first population the young and the second the old. The reason I did that was just because they presented the younger information first and then the older, so I like to take what information I have first and call it population 1. You could flip-flop here, and then everything would be opposite until the end, and you would get the same conclusion. So, as far as the null is, the null hypothesis, if I didn't stress this enough earlier, it's always going to be mu1 equals mu2 whenever we're doing a mean problem. The alternative hypothesis, however, is really going to depend on whether or not you set the young as the first or the young as the second population. Because we set population 1 as young, and the claim says that old men weigh less, we need this to be the smaller number because that's the old average. And the old average is supposed to be smaller than the young average. So what I did is you always point to the smaller thing. So it's a greater than problem, so it can point to the lower weight, which is supposed to be the older men. My significance level here was given to me in the problem, 0.05. So I wrote that. Here's that test statistic that was presented to you earlier. I plugged all of this information from up here into this test statistic. So you'll see the first mean, 176, went here. The second mean, let me get obnoxious here. The second mean right here went right here. The first standard deviation went right here. The second standard deviation went right here. This all typed into my calculator, putting parentheses around the top putting parentheses around each of the individual fractions, gave me an answer of 8.56. Because it's a greater than problem, I did TCDF starting with the test statistic and going to the right, so 10 being my infinity here. So 8.56 to 10. The larger n was 1657, so I did n minus 1, 1656. And I got back an answer of 1.27 times 10 to the negative 17th, which is so small I just called it 0 plus. And 0 plus is less than 0.05, the significance level, so we're able to reject the null hypothesis. And my conclusion was that there is sufficient evidence at the 0.05 significance level to show that old men weigh less than the younger men. So this was a little bit different. I know I didn't work anything out for you. I just kind of explained all my work here. So if that confused you, just reach out and I can help you. But hopefully you've got a pretty good understanding of how these hypothesis tests are going, and you'll be ready to do the homework.